Hi, this is Mr. Gallagher, and this will be our second lesson on piecewise functions. As we said before in our first lesson, piecewise functions are basically a function which is made up of two or more pieces or equations. So for the one here on the left, we'll have a top and bottom part to it, which will relate to two different parts of lines on our graph. Just like our second piecewise function has a top, then a middle, and then a bottom, and each of these three levels are going to relate to a different piece of the lines that are on the graph below. So for our first example here, we have to graph the following piecewise function and then identify the domain and range. So we have the function g of x equals 2/5 x plus 1 if x is less than -3, negative 2x if -3 is less than or equal to x, which is less than or equal to 0, 3 if x is greater than 0. Well, if you remember from our last example, we begin with the information on the right. And there's a little bit more going on here than in our last one. But if we start with the top statement, x less than -3. Well, this is the information that determines where our breaks will happen in our piecewise function. So we're going to have some dotted lines that we have to put on our graph. Well, the giveaway here is the numbers that are used. So we can see our first equation is going to be relevant when x is less than -3. So we'll go over 3 to the left on the x-axis, and that's where our first dotted line will go. Well, if we look to the bottom one then, x greater than 0, well then that tells us then 0, that's right here at the origin, and that would be a line just going straight up and down the y-axis. And then that makes sense too, because our middle part has x being in between -3 and 0, and that would be this region here in the middle. So we have 1, 2, 3 regions that will make up the three different pieces of our function. So now that we can start looking at the different equations which make up our piecewise function. The top one, 2/5 x plus 1, well, we're going to think of the equation y equals 2/5 x plus 1. And so the plus 1 refers to the y-intercept, and then 2/5 will be a positive 2, so we'll rise 2, and then go across 5, and that's what the line will look like. Then our second equation, -2x, well, we're going to think of y equals -2x. Now there's no y-intercept shown here, but when we don't have a number, we know that that means that it's 0. And then -2 means we'll go down 2 and across 1, down 2 across 1. So we draw our line in. And then our bottom equation, it just has a 3, and then once again that'll be y equals 3. So we'll have to go up to 3 on the y-axis, and since there's no x, we know that that means there's going to be a slope of 0, which means it's a horizontal line. So now we have all three of our lines on our graph, but if you remember from our last example, we kind of have to erase part of each of them because each line is only relevant for one part of our graph. So when we start at the top one, our first equation, y equals 2/5 x plus 1, that's this line right here. Well, that's only relevant when x is less than -3. So that would be everything to the left of our first dotted line here, our first break. So we can erase the other half, the other side of that line. Our middle line, y equals -2x, well, that line's only relevant in between the two break lines. So we could erase both the left and right side of that line. And then our horizontal line at 3, that's going to be relevant when x is greater than 0. So that's going to be everything to the right of the y-axis, or to the right of our right dotted line. And then the last thing that we have to do is identify what the endpoints should look like for each of the lines. So for our first one, since x is less than -3 and not less than or equal to, we'll put an empty circle, not filled in. For our middle, notice how there's less than or equal to for both sides, so that means we're going to have filled in circles on both sides. And then for our bottom, x is greater than 0, and once again that's going to be a circle that's not filled in. The last part of this is to identify domain and range, and once again, domain, we're thinking about how far to the left or right my graph will go, and you can see it's going to go off to the left forever. It's also going to go off to the right forever. And then we're going to look at the middle to make sure there's no gaps or anything. And as we move along here from the left, we approach -3, and then it jumps up to our middle line, and then it travels along, and then it'll jump back up to our horizontal line. So there are no gaps. So our domain is going to be all real numbers. Our range, we're thinking about, okay, how far up and down will my graph go? Well, you can see here up at the top, there's never going to be a spot higher than 6. And we can go down, and then here we actually are a part of 2 different lines. And we'll continue going down, and then it jumps over here to the left, continue going down, and it will really continue going down forever. So we just have to represent the range as saying it cannot be higher than 6, it can be at 6, and then it will go down forever from there. So all y such that y is less than or equal to 6. And for our second part, we'll take a look at another piecewise function, but this time we'll look at it in reverse. So we have the picture of the graph, and we have to identify what the actual function would be written out. Well, if we start f of x equals, and we know we're going to have 3 levels to it because we have 3 different pieces on the graph, and just like when I was graphing, I start with the break spots because I think that's the easiest to identify, and that's really where the one line ends and another begins. So it looks like we have a break here at +1. All right, so our first equation looks like it's everything up to +1. So when x is less than, because this endpoint's not filled in, when x is less than +1, that's going to be our first line. This line, this little piece of a line here in the middle, that goes from +1 to +2, and since the endpoints are both filled in, we're going to have less than or equal to signs to represent that. And then our third piece here at 2, that's going to be when x is greater than 2. And since we don't have that filled in, we won't have a greater than or equal to. It's just going to be greater than 2. So that's the right side of our function, but then now it's important to identify what each of the 3 equations are. So for my first equation, I have to think about the slope and the y-intercept. Now my y-intercept is up at 1, 2, 3. And then my slope looks like it goes up 2 and over 1. So that would be y equals 2x plus 3. And then when we write that into our function notation, we just don't put the y in front of it. So 2 plus 3. This one in the middle here is a little bit trickier because we kind of have to envision what would happen if we extended it back. And it looks as though it would go through at +2. So it looks like my y-intercept is going to be 2. And then my slope, well, this clearly is going to have a negative slope, down 1 over 1. So a slope of -1, y-intercept of +2. So y equals -x plus 2. And then our last one, you can see that we have a horizontal line once again. And remember, when we have a horizontal line, it will just mean that our x is 0. So since we're up at 3 on the y-axis, y equals 3. And then in our function, just 3. So f of x equals 2x plus 3 if x is less than 1, -x plus 2 if 1 is less than or equal to x, which is less than or equal to 2, and 3 if x is greater than 2.